So today's session is on customer-facing analytics with StarRocks. My name is Sida Shen. Thank you guys for joining this session. So first, let's go over the agenda first. So first, we're gonna talk about what is customer-facing analytics, the challenges, with joins, with not only fast but fast consistently, right? How to hit your SLA goals, that's pretty difficult, right? And then we're gonna talk about some of the technologies and features, to achieve these requirements with StarRocks. And then we're gonna provide two reference architectures, right? So first, our reference architecture with real-time analytics. When you want to have like the best possible query performance and you want to have the best data freshness, right? With 10-second data freshness, even with mutable data. And then it's another architecture really focused on data governance, right? So single source of truth on your data lake on the open format while still achieving this kind of, sub-second data warehouse like performance for your customer facing analytics workloads, right? And then we're going to take a sneak peek into how industry leaders are future proofing their data architecture. Actually, some of them are presenting in the StarRocks Summit today. And then I'm going to share a link to the customer facing analytics white paper we just created with StarRocks and CelerData. So let's get started. So customer facing analytics is basically the process of directly serving analytics to your end users, right? So on the right hand side, you see a screenshot that is our YouTube Studio page, right? It shows the real time view, watch time, and subscriber gain. That iceberg video we made, right? And that right there is basically customer facing analytics, right? It's very high stake. It's typically company's revenue driver. It's your competitive edge. So it's something that's very important. People are pushing the boundary on this kind of workloads. Some example can be like say in ad tech, Google ads, Pinterest ads, fraud detection, TRM labs they're presenting today, Coinbase they already presented today, right? Fraud detection for financial institutions or just external facing dashboards like YouTube Studio, DoorDash, and many other apps, right? Customer facing analytics is everywhere and it's gating and it's making a difference. But it's actually pretty hard to do, right? So here I will go over a few challenges we see in the field, right? So first is the challenge with joins and denormalization, right? So first, your data is relational by nature, right? But a lot of legacy OLAP solutions, especially those real-time solutions, were not built, with a relational data model in mind, right? They either don't support join at all, right? Not even on the syntax level, right? Or they only allow single node join, no distributed join, right? So no data shuffling service, meaning you cannot really run big table join big table. You can only run like a dimension table join dimension table. Nobody really does that. But like a dimension table join like a fact table, right? But two fact table join are not really possible, for those solutions. And unoptimized performance, right? Yeah, they can do that on scale, but really unusable in real time, especially for customer facing like workloads, right? So as a workaround, users are forced to denormalize everything, basically meaning to pre-join all of the table into a big flat table. But denormalization comes with a very hefty cost as well, right? So first you have to consider the very complex and expensive pipeline, right? Let's say you're doing something batch, right? You're using some batch processing tool like Spark. Managing 1,000 Spark job, yeah, it's bad, but it's manageable, right? For a lot of folks. But if you want to do real time, a batch processing tool like Spark is not going to keep up. So you need to introduce incremental processing, stream processing, and that's a whole another special field that requires very specialized techniques, right? And it's very very expensive and difficult to do. And then you have to consider the difficulty on schema change, right? Let's say you have a smaller table and a larger table, right? Because your query engine cannot really run joins on the fly, so you create a denormalized table, right? Let's say the smaller table is 100 rows and the fact table can be some transaction, half a trillion rows, right? If you want to do a schema change on the smaller table, on the dimension table, one column, right? Not only you have to change that smaller table, but you have to rewrite every single row in the big denormalized table with half a trillion rows with all of the columns, right? That's very, very expensive. This data backfilling uh, caused a lot of troubles. There actually one user that of StarRocks, they used to be on Apache Druid. They run the metrics platform, right? And each metric change or adding a metric took hours or even days just because of data backfilling caused by denormalization, right? And then it's a storage explosion. Duplicating field across tables can easily inflate your storage, in our experience, 10 times or even more, right? This is not that, I use object storage, I reduce my storage cost from like 1 to 10%, right? This is raising from 1 to 10 times. This is very, very expensive. Even, for now, storage is getting a lot cheaper, but a lot of solutions, they don't utilize object storage as their persistent storage. Storing everything on your SSD while 10 timing it is just horrible, right? Even with modern tooling, denormalization is still, operational task. It's gonna grow as your business grows, and most of the time it grows faster. So, and this is denormalization and join. And next is query resilience, right? For customer facing analytics, sometimes, most of the time, hitting SLA. So not having slow queries is actually more important than having average fast performance. You're facing impossible SLAs, right? So first, low latency, you have to satisfy low latency under peak loads, right? High concurrence with thousands of simultaneous users and very strict SLAs with no room for error, right? And it's very difficult to achieve. First of all, workload changes, right? You don't know when one of your customers gonna run a promotion, right? And just 10 times their traffic, right? And also unpredictable and often very skewed data. And this is very specific for those B2B customer facing analytics kind of scenario, right? B2B SaaS. It's very often that you have 20% or 10% of your customer that represent like more than 50% of your data set. Your biggest client probably has like 20% of your entire data set, right? So it's very easily skewed. And that's horrible for analytics performance, horrible for data scanning, right? And very difficult thing for a storage engine to solve, right? And also infrastructure failures because customer facing analytics has such a strict SLA. Sometimes it's more than the cloud instances that you run. So when the instance fail, what do you do? How do you keep your performance up, right? And also resource contentions between your clients, between your different tenants, and also when data change, cache miss, and index gets outdated, and those creates a lot of slow queries as well, right? And when anything fails, poor user experience, bleach SLAs, and you have to over provision, to compensate for the rare peaks that, if your underlying data infrastructure cannot withstand, right? So your engineering team end up, stuck firefighting instead of actually building and wasting a lot of cost. So what is the solution? StarRocks, right? The topic of the summit today. StarRocks is a lakehouse query engine, right? So it can be deployed in two ways. So first, you can deploy StarRocks as a data warehouse with its own storage and file format, right? So it features storage and compute separation. So even the storing in StarRocks file format is still persisted in cloud object storage. So you get the benefit, the scalability, the cost efficiency of object storage, and you get, right? So you're able to scale, with the workload, right? So it supports sub-second queries at scale, best-in-class performance, do on-the-fly join with no denormalization pipelines. I'm going to go into how we do that exactly a little later, right? And real-time mutable data directly on columnar storage with StarRocks' own format, right? You're able to get 10-second data freshness even with mutable data, right? And also features a storage compute separator architecture. StarRocks also live within the lake house or the open data format kind of world, right? So you can ditch the StarRocks storage engine as a whole and connect it to, let's say, Apache Iceberg REST catalog, and then gain access to the Iceberg metadata and directly query the Iceberg data, right? So you don't have to duplicate your data. And by just doing that, StarRocks is also able to get data warehouse like performance, sub-second query latency directly on your open data lake, on your Apache Iceberg, on your Delta, and your Apache Hudi tables, right? And also it supports all of the popular table and file formats, including Delta Lake, Iceberg, Hudi, Pymon, and all of the files, right? So this is just an intro for StarRocks. So how do we make join run fast enough, right? So first, the most important thing is actually computer architecture. Is how your database, how your query engine execute each one of the query, right? So these three are very abstracted three kinds of compute architectures. So first is scatter gather. It's a very simple architecture, right? But really easily bottleneck on the gather node, right? In terms of join, right? It's able to run distributed join, but it's not able to do data shuffling, right? So the only kind of distributed join it can run are like bucketed join. Basically it's a process of bucket your data the same key as the key you're going to join it on, right? And also a broadcast join, right? So basically broadcast your smaller table to all of the nodes, right? So it's going to bottleneck on a single node, and it's not going to work for big table join big table kind of queries. One example for this is ClickHouse, Apache Druid. They all follow this kind of architecture without the ability to do data shuffling, right? It's actually a good, simple, a very robust architecture for low cardinality aggregations and single table queries like log analysis, right? And next is MapReduce, stage by stage compute. One example is Spark is a variant of that, right? It's able to do data shuffling, but for every data shuffle, all of the results are stored to disk, right? Temporarily. This is not to slow down performance. This is not to slow down performance, but to more optimize for those batch workload that runs for hours, right? And then is MPP architecture, which is what StarRocks built on, right? Supports data shuffling, but shuffling between the memory of each node, right? So you get the best possible performance, and you're able to run join queries on the fly, scalable join queries on the fly, including not only small join big, but big join big as well. So this is computer architecture, and the next is query planning. Query planning is especially important when joins is in consideration, right? With join in consideration, the search space for possible ways to execute a query, just to join a query, just to join a few tables is enormous, right? The difference between an optimized plan and an unoptimized plan can be several orders of magnitude big, right? And cost-based optimizer is the state of the art uh, mechanism to solve this join problem right now today. So what it does is collect statistics on your data periodically and estimate the cost of the plan and select the best one, right? Select the cheapest one. So StarRocks cost-based optimizer is innately built and deeply integrated with the execution layer we just talked about and the storage layer, right? And that was pretty pretty difficult to get right. Yeah, it took us like a year and a half, 2 years to get this really mature. Like 4 years ago, right? Thank God we have a community. Thank you, StarRocks users. We're able to iterate with you guys. So this is query planning, and next is performance, right? So with all of the features that StarRocks support, so this is a benchmark between StarRocks and ClickHouse and Apache Druid, right? On SSB 100 gigabytes. So SSB um, is a multi-table benchmark test. But the folks at ClickHouse, they made a variant of the SSB benchmark test into a flat table, right? So basically only running the aggregations on the fly, not the joins on the fly, right? And everything with the multi-table there, StarRocks, that is the original SSB test with multiple tables. And everything with a flat is a flat table, right? It's the StarRocks flat, ClickHouse flat, Apache Druid flat. With a flat table test, StarRocks is the fastest of all, but the interesting thing here is StarRocks multi-table is actually faster than Apache Druid's single table performance. So basically, you're kind of running the joins for free, right? And join is one of the most difficult, most expensive thing you can do with a SQL query, right? And StarRocks multi-table is almost as fast as ClickHouse single table, and that really speak a lot, into StarRocks join performance. So next is low latency with SLA, right? And first of all, it's caching, right? Cache gets invalidated. It's probably like the biggest reason, you get a slow query in production, right? So first we build a proactive cache warm-up, so you're able to pre-populate cache, with your frequently accessed data, right? So you eliminate the cold start problem, right? And also we support compute replica strategy. So actually, one piece of data we store multiple copies of cache of that data into different nodes. So if you encounter node failure, you have another copy of the cache to fall back to, right? So keep your SLA up. And segmented LRU, right? So this is a mechanism to make sure that a large query is not going to flush the entire T of the LRU, right? So keep your actual hot data in your cache at all time, right? And low latency on data lakes. We've been working on our own storage for many, many years, right? And we're actually porting a lot of the features we built for StarRocks storage engine to the data lake, to Apache Iceberg, right? Things like statistic collection, things like global low cardinality dictionary to accelerate low cardinality queries, right? And primary key, foreign key constraints, and smart metadata fetching. Those are the experience we gained serving StarRocks as a data warehouse, right? And now we're moving that kind of those features and the same experience, the sub-second query experience to the data lake as well. And the next is data skew, right? We just talked about data skew is a very big problem specific to B2B SaaS like customer facing like workloads, right? So you have a time that you have to query on, right? To filter on, and then you have the tenants you have to filter on, and those are all very very skewed, right? So StarRocks has two solutions for this. So first of all, with multi-level partitioning, right? So if the multiplication between number of time partitions and the number of tenant partitions, the multiplication of that is, let's say, less than 1,000, this is gonna work, right? So basically what you do is you just partition by the two fields, right? So you immediately isolate noisy tenants, right? And you get O1 time complexity when you do your filters, right? So sub-second queries, per tenant, right? But if you have a finer granularity for time partition, or it's just many tenants that you have, right? So it's not possible to do a multi-level partition because there will be so many partitions out there, right? So what you can do is you can do a time partition plus a composite hashing between your tenant ID and your user ID, right? And then you want to order by those two, right? So when you filter by tenant ID and user ID, you get O1. But if you only filter by tenant ID, it's sorted, so it's log and time complexity lookup. So the filter is still quite fast, right? So this is how we solve data skew. So here I want to present two reference architectures. So first is a real-time reference architecture. So basically use the SaaS internal format to get 10-second data freshness even with updates and deletes, right? So this is going to give you the best possible data freshness, right? So you can have data ingested directly from your Flink and Kafka topics. And this is what the StarRocks ingestion pattern look like, right? So you have your Flink connectors, your Kafka connectors. You either want to use routine load or your Kafka connect, right? So basically you want to use StarRocks resources or Kafka resources, right? Depends on you, right? So this is the real-time reference architecture. I have more of that in the white paper. And then it's a lakehouse reference architecture. So this focus a lot more on governance, right? So you want single source of truth on open formats, on your Apache Iceberg tables, right? So StarRocks can directly query your data lake and still get relatively similar performance as of the real-time reference architecture, right? So a lot of features we built to support this kind of performance. So StarRocks on internal format versus StarRocks on Iceberg, it's actually virtually just less than 10% difference, right? And there's another query engine on top of Apache Iceberg. StarRocks is almost 7 times faster now, right? So this is the Lakehouse reference architecture, and there are more StarRocks customer-facing analytics success stories, right? So first, it's demand-based. I think they're doing this presentation in the other room right now, so you're welcome to check out the recording, right? So denormalization to join on the fly, right? They were using ClickHouse, they couldn't really do join on the fly, so they denormalize everything, right? And after they moved to StarRocks, no more denormalization, 90% storage saving, simplified data pipeline, and actually the ability to do real-time analytics because no extra pipelines to manage, right? And also they were able to consolidate 40 plus ClickHouse cluster into one StarRocks cluster. And then HerdWatch, they're like a cow, a livestock monitoring SaaS. So they're running StarRocks directly on Apache Iceberg to serve their customer-facing dashboards. Right, they went from Athena to StarRocks, so latency went down from 2 to 5 minutes to like around one sub-second. Right, and they were able to unify everything on Apache Iceberg, single source of truth on Apache Iceberg. And TRM Labs, they're also a presenter here today. From BigQuery to Lakehouse, they built a petabyte scale data analytics platform with Apache Iceberg and StarRocks, serving customer-facing analytics with very complex on-the-fly joins with hundreds of terabytes of data. Okay, so this is actually all I have. Please make sure to join the StarRocks community, join the Slack channel. And now we have 3 minutes to do some Q&As. So first question, what impact, if any, does shared data have on query latency versus share nothing? Is it better or worse for a specific type of queries or affect the query planner? So the difference would be the IO, right? To fetch the data out of the shared storage, your object storage, right? The IO is going to be the only difference in terms of performance difference, but we do have a very well designed, complicated caching system to make sure that to make it best effort, so no data is directly fetched from your object storage, so everything is local disk. But the difference would be the IO, right? So if you have compute heavy queries, it's going to be less impact. But if you have very scan heavy, scan bottleneck kind of queries, it's going to bottleneck more, if the cache misses. Right. Okay, thank you. Next question. Is StarRocks FE using Trino? Is StarRocks FE using Trino? No, it doesn't. Trino is another project very similar to what StarRocks does on the data lake, right? No, StarRocks FE doesn't use Trino. Okay. We're facing a similar challenge at my company. We're currently planning to migrate our reporting system from Athena to StarRocks. Right now, some queries take between 5 to 20 minutes to run, and we expect them to execute in just a few seconds after migrating. Yeah, so Athena, I think the biggest challenge with Athena is it doesn't, you cannot really tune it to make it run faster, right? So, after you switch, I'm sure, sub-second or in a few seconds is doable. Okay, really appreciate that. Thank you. Thank you everyone for I think we got another question. We are currently planning to serve tens of thousands of tables to StarRocks. Are there concerns require around registering materialized views on top of StarRocks? Not really. If you have tens of thousands of materialized view, the query rewrite might take more time to process. But having many tables, I think is fine. Just not tens of thousands of materialized views. Okay, we're at time. Really appreciate everybody joining. Hope you have a wonderful time at the StarRocks Summit. Very thank you for joining. Appreciate that. Thank you. See you guys again next time. Thank you.